You are given a string S that forms a valid arithmetic expression. It may contain digits, plus and minus signs, parentheses, and spaces. Your goal is the integer value of the fully evaluated expression. Example 1, 1 plus 1. Read the first one, that is our starting value. The plus sign adds the next one, so 1 plus 1 equals 2. The expression evaluates to 2. Example 2, 2 minus 1 plus 2. 2 minus 1 leaves 1, then plus 2 finishes at 3. Spaces are ignored, only the signs and digits matter. If we strip away parentheses, a mathematical expression is just a simple conveyor belt of numbers. By walking from left to right, we can parse multi-digit integers and instantly add or subtract them to a running total. We do not need trees or complex parsers for standard addition and subtraction, just a running tally. To make this incredibly smooth to track, we can unify addition and subtraction. Instead of performing different operations, we treat every operator as a sign multiplier for the next number. A plus sign sets our multiplier to +1, and a minus sign sets it to -1. Every time a number is built, we multiply it by our active sign and simply add it to our running total. But things get tricky when parentheses enter the game. Parentheses break our linear flow because they represent an isolated subproblem. In this expression, we are right in the middle of computing 2 minus something, but we cannot finish that thought until we evaluate what is inside the brackets first. Our current calculator state is effectively frozen. When we hit an opening parenthesis, we need a safe place to store our current state so we do not forget it. We can push our frozen running total and our pending sign onto a stack. With our old context safely put away, we reset our calculator completely back to 0 to evaluate the inside of the brackets as if it were a brand new, independent problem. Now we calculate the inside of the brackets exactly like before. 3 plus 4 gives us a mini result of 7. The moment we hit the closing parenthesis, it signals that our subproblem is fully resolved. It is time to bring back our stored memory and finish the original calculation. To merge everything back together, we pop our old state off the stack. First, we retrieve the pending sign, which was a minus, and apply it to our bracket total of 7, changing it to -7. Finally, we pull out our old running total of 2 and add it to our result. Just like that, the past and present combine seamlessly to give us -5, all achieved in a single left-to-right pass. To implement our calculator, we set up our memory dashboard. We need a variable for our running total, a multiplier for our active sign defaulting to +1, an integer builder for multi-digit numbers, and an empty stack to remember our context when entering brackets. As we scan left to right, we first encounter the character 2. Since it's a digit, we convert it and store it in our number variable. When the pointer moves to the minus sign, it signals that our number is fully built. We add this number multiplied by our current sign to our total, resetting our number builder, and then flip our sign multiplier to -1. Next, we hit the opening parenthesis. This tells us we are entering a brand new subproblem. To avoid losing our place, we push our current total of 2 and our pending negative sign onto the stack. With our past state safe, we reset our workspace total to 0 and our sign to +1 to evaluate the inside of the brackets cleanly. Now we process the interior elements exactly like a normal expression. The digit 3 updates our number, the plus sign pushes it into our internal total, and the digit 4 populates our number builder again. We stop the moment we hit the closing parenthesis. The closing parenthesis signals the end of the subproblem. First, we complete the final addition inside the brackets, bringing our inner total to 7. Next, we restore our history. We pop the sign multiplier off the stack and multiply it by our result, giving us -7. Then, we pop our historical total of 2 off the stack and add it to our value. Our current total updates to -5. We have reached the end of our string. With all characters processed, our running total holds the final correct mathematical answer. We return our result, having evaluated the expression flawlessly in a single linear pass. Let n be the length of the expression string. Time is order n, each character is read once, and every stack push or pop is constant time. Space is order n in the worst case for the stack when parentheses nest deeply, we only store saved totals and sign multipliers, not copies of the string. Here is the full single-pass calculator in pseudocode, for variables, one loop over the string, and stack pushes whenever we enter parentheses. Define calculate on the input string s. Initialize total, sign, number, and an empty stack. Walk the string one character at a time. Digits extend the multi-digit number we are building in number. Append the new digit, multiply number by 10 and add the digit value. When we see a plus or minus, the current number is finished. Fold sign times number into total. Clear number and set sign for the next number. An open parenthesis freezes our current progress. Push total and sign onto the stack. Reset the workspace to 0 with sign 1. A close parenthesis means the inner sub-expression is done. First complete the pending number inside the brackets. Pop the saved sign and multiply it into total. Pop the saved outer total and add it back in. After the loop, flush the last number and return total.